Hi, I'm John Reister from Vasona Networks, and Vasona Networks is about managing RAN congestion to improve the quality of experience for the users. And we achieve that by performing traffic management in between the RAN and the core network, and the end result is that the operator can reduce cost, reduce capital expenditure, and through happier customers, improve their revenues and reduce churn.
You help operators tackle mobile data congestion. Why is this a problem?
So when we look at the congestion in a network, a lot of people are familiar with the concept of a peak hour, and they think of congestion as lasting in a sustained fashion for an extended period of time. When you actually look at an individual cell, you see a lot of peaks and valleys, big, huge spikes, followed by where the traffic slams into the capacity of the cell, and then the traffic throughput plummets as there's a back off and there's a big valley, and you get this huge oscillation of these peaks and valleys. You end up in the peaks creating a lot of latency, and then in the valleys you're actually underutilizing the network. In wireless, it's especially a problem because the capacity fluctuates almost as much as the traffic. So as UEs move within the cell, the capacity that's available to an individual user and the aggregate capacity in the cell actually changes significantly. So you have the situation where the flows can never really stabilize in that cell and it continues to fluctuate. And then you layer on top of that the fact that apps have different needs. Some apps, the user is looking at the screen, looking at a video, looking at browsing. They want to see a very smooth experience. If you have an app like your email is synchronizing, a less smooth experience is completely acceptable. So you've got sort of a variety of need struggling against a network that has fluctuating capacity and is trying to carry these huge spikes in demand.
So how do you solve the problem?
So the way we solve the problem is to look at a cell holistically. So we first we sit in between the RAN and the core inline, where we can observe the control messaging that passes through the network, as well as see all the GTP tunnels that carry the user data. And the first thing we do is, by looking at the control traffic, we can map where the UEs are cell by cell, so we know which UEs are contending for the traffic in that cell. Then we classify the traffic, and we can figure out for each flow whether it's video, audio streaming, background traffic, social networking, browsing. Once we've identified that, we look at the conditions in the cell, and we can actually figure out the latency as well as the number of packets in flight that are passing through the RAN. If there's no congestion, we don't take any action. We just observe what's happening and we produce some nice analytics on it. But if there is congestion, we then have queues for every flow, for every UE in the cell, and we manage the traffic going through the cell to keep the latency very low and ensure the video gets through uninterrupted. The browsing goes through with the quickest page download time. And then we get continuous feedback on that. So our dynamic rate control with feedback mechanism, which we call DRCF, has continuous feedback that allows us to update on a millisecond by millisecond basis how we're scheduling and how we're emitting the packets down through the RAN.
So how is your solution to solving cell congestion different than, say, some other companies?
Sure. A lot of some companies have tackled congestion by compressing the traffic and altering the content, and we don't touch the content at all. We don't modify the content in any way. And I think most importantly, we're actually able to see who's contending on a cell-by-cell basis. So we're managing a cell by itself. We're managing each cell and the set of users in that cell together, so we can figure out exactly what's contending. We won't reduce bandwidth when there's no congestion, so we allow the optimum experience as a result.
So can you give me an idea of what your results have been in the deployments?
Yes, we've deployed we have commercial and pilot deployments throughout the world, and what we've observed is around a 35% reduction in latency and approximately a 30% improvement in video and browsing bitrate during congestion. So during those times of congestion, we're delivering more video bits, more browsing bits, and we're reducing the latency, so the experience is much improved. One of the huge trends happening across the industry right now is the massive surge in encrypted traffic. So 3 years ago, around 7% of traffic was encrypted. As of last summer, it was around 24%. And now it varies from market to market, but we're seeing 50 to 60% of all the traffic is encrypted. And when the traffic is encrypted, the techniques where you try to modify the content, or if you try to cache the content, those techniques don't work. So our new classification engine can classify the mobile encrypted traffic, whether it's video or browsing or audio streaming, and we can classify it and then use our traffic management techniques on that encrypted traffic. Another major area is we've introduced a daily dashboard. So we now, as part of our Smart Vision suite that provides management and insight of our solution and insight into the traffic and the applications and the network performance, we now at 6 o'clock in the morning, we create a summary of the previous day, and we can lay out how the network was performing, and we cover not just the network performance, but the quality of experience that was actually delivered. So we're actually indicating how many video stalls, the duration of those stalls, and we can lay that out. And if yesterday was, say, Tuesday, we can then compare yesterday, Tuesday, to the previous 4 Tuesdays. So you're essentially looking at yesterday and saying, how is that different than a normal Tuesday? And you get this in a snapshot, and our system then emails it to the operations manager of the network and can see that. And then the last area we've announced at the show here is our Smart Connect. We collect a lot of cell metrics and a lot of information about how the network is performing and how the user's experience is. We can now export that data to third-party systems or to operators' own Hadoop or big data platforms.
So what's next for Vasona Networks?
Yeah, it's a really exciting time. The growth in traffic through mobile networks just continues to explode. We're adding in upstream capabilities, and we're also looking at how operators can have better levers to control the experiences that they deliver to their customers. So stay tuned for some of that capability to adapt the network and tune the network to what the customers need.